Buenos días, bienvenidos al tercer día de actividades del Congreso Internacional en Mejora de Procesos de Software. Pues ahora me toca presentar la conferencia magistral titulada No enseñar estándares de ingeniería de software a futuros ingenieros de software. ¿Negligencia? Pues ahora tengo el honor de presentar al doctor Claude Laporte. Me voy a permitir leer una pequeña reseña del doctor. El doctor Claude Laporte ha sido profesor desde el año 2000 en la Escuela Superior de Tecnología en Canadá, donde más de 10,000 estudiantes de ingeniería están estudiando. Él ha enseñado ingeniería de software. Sus intereses en investigación incluyen la mejora de procesos de software en entidades muy pequeñas, así como el aseguramiento de la calidad de software. Él ha trabajado en el Departamento de Defensa, para el Departamento de Defensa, y el transporte por más de 20 años. Él ha recibido un grado de maestro en física por la Universidad de Montreal y un grado de maestría en ciencias aplicadas por la Escuela Superior Técnica de Montreal. Asimismo, un doctorado por la Universidad British Occidental en Francia. Él ha sido nombrado doctor honoris causa por la Universidad de San Martín de Porres en el 2013. So I'm going to change the language. Claude, thank you very much for accepting to be with us another year again. This is a very special year for SIMS because it's the 10th edition of this conference. So thank you very much for stay with us virtually, but you are here. Thank you very much. So it's all you.
Thank you very much, Mirna, and thank you for inviting me. So my presentation, I will be speaking in English and you will be seeing my slides in Spanish. So as you can see, I'm going to address the topic about why are software engineering professors not teaching software engineering standards. Just for your information, I've been involved in standardization for about 40 years, either in the military or working as a process manager or process engineer in the industry. And also I've been teaching software engineering for about 25 years at ETS and other places. So the topic today, after a quick introduction, we're talking about why bother with standards. We'll talk about quality and productivity issues, software engineering standards, and the 29110 standard, for which I am the main editor. And briefly, we'll talk about the success story, and briefly also we'll be talking about a survey that we've done about the teaching of standards. So the first topic is the introduction. So let's talk about what we call an impossible scenario. So an 8-person company that developed a computer control valve, produced a valve and sold that computer control valve to a company in a chemical plant. And the contract indicated that the software engineering shall be developed according to the IEEE series of standards. And one of the developer did not know about one of the standard, the IEEE 1028. And for your information, the IEEE 1028 is the standard that presents how to perform software reviews, as an example, how to perform software inspections with trained participants and with a facilitator. So as a consequence, okay, one of the consequences is the valve malfunctioned and it caused a lot of damage in a chemical plant. And one of the technicians had to be sent to an hospital. And then the customer that bought the computer valve decided to launch a legal action against the supplier of the valve. So in court, the judge decided that the supplier of the computer control valve did not fulfill the requirements of the contract. The judge blamed the software engineer for negligence by not performing the review or inspections of the requirements using the 1028 standard. And also he also ordered the supplier to rework or correct the software at no cost to the customer. So outside the court of justice, the president of the company fired the developer. And right after, the developer contacted the lawyer to start a lawsuit of negligence against the university that he attended. And also that information was broadcasted on the network, social network around the world. And it became viral because in many universities, they were not teaching software engineering standards to software engineering students. So the background of that talk today, it started in New Delhi back in 2008. I was attending a meeting over there. And after my presentation, someone in the audience asked me if a professor that do not teach software engineering standards to software engineering students could be accused of negligence. And this was the first time that that question was asked to me. And after thinking about a few seconds, I said yes. And you can see what I mean by negligence in the box below. And this this allows us to write an article with my co-author, with Myrna from SIBS and from CMAT. So this is what we'll be talking today. So the objective of the article is to promote the teaching of software engineering standards as sources of documented knowledge. So the knowledge documented from thousands and thousands of projects. Also to promote discussions about standards amongst professors that teach and those that do not teach standards. Also amongst professors and students to talk about the advantages, disadvantages, and ethics, and also amongst professors, students, and enterprises about the use of standards. So the paradox is as follows. Software engineering standards are sources of codified knowledge that have been captured from thousands of successful and failed projects. And software standards support organizations in delivering to their customer all the functionalities with all the quality characteristics like maintainability, portability, security, etc., within schedule and budget. On the other side, software engineering standards are not used or they are ignored by many professors that are mandated by the university to transfer knowledge of proven software engineering practices to their software engineering students. So the consequence is that many students will end up in industry with a deficit of knowledge about how to use standards as well as their advantages and disadvantages. So my question to you, is it acceptable to you as students and maybe to you as people from industry? And I would say that the answer is no. Well, just for a few seconds. So there are many laws of nature, and unfortunately, those laws of nature are the foundation of many many engineering disciplines like electrical engineering, mechanical engineering, chemical engineering. And my question to you is, can you name a law of nature that is a foundation of software engineering? So you can think for a few seconds, you can think for many hours, and the answer is there are none. Software is based on laws of logic and mathematics. So we don't have laws of nature as a foundation of the software engineering discipline, but the only thing that we have are standards that have been approved by consensus by a recognized body like the IEEE, the ISO, or other recognized body to help us in producing higher quality software. So let's talk for a few seconds about the Code of Ethics. IEEE and ACM has published many years ago a Code of Ethics that lists 8 principles of that are related to the behavior made by software engineers. And it does apply to students as well as to professors. So one of the principles is the principle number 3 about the product. So it says that software engineers shall ensure that their product use the highest professional standard. And I stress the word shall because it is an obligation. It's not an option. I say again, it is not an option. It is an obligation that software engineers, including students and professors, shall use software engineering standards and follow them when developing their software. And also principle number 8 about yourself as either a professor or students or people in industry, you should be learning all your life, and you should be improving your knowledge about relevant software engineering standards. So talk about standards and negligence. So standards, as I said, practices. And courts generally review the application of standard as important evidence that engineers perform their work with appropriate diligence and responsibility. If accused of negligence, an engineer can cite the use of standard when he or she conducted his work as a software developer to demonstrate that it was performed in accordance with codified professional practices. So my question to you is, if an engineer could be accused of negligence, okay, why could professors teaching future software engineers who ignore or do not teach software engineering standards cannot be also accused of malpractice? Okay, so now let's go to another topic. Why bother about standards? Okay, so in life, all of us make errors. Okay, all of us. Okay, even the bright people, even the people with 140 with an IQ of 140 will all make errors. Okay, it is part of the human being. So those errors produce defects, and those defects will could eventually lead to failure. Minor failure or catastrophic failure when you can harm or kill people. So the main questions that we have as software engineers and software engineering professors is, how can we prevent those errors? And how do we detect those defects? So we want to reduce the preventions of error. We want to reduce errors, and also we want to detect defects because we know that we'll still make some errors. So the software engineering standards can help in preventing errors and also reducing defects. Let's have a look at the House of Quality for a few seconds. So House of Quality is built of many practices, starting from on the left with standards and models, with configuration managements, review audits, verification and validation, code of ethics, measurement, risk, checklist, etc., etc. And those practices are documented in a quality assurance plan. So the practices that have been selected for a specific project are documented in the quality assurance plan. And somewhere in the organization, some software quality people will make sure that the plan is followed. And all of that will happen only if there is a strong management support, both financially and with also the commitment to produce quality software and to use standards. And all that will provide the organization to produce quality software, good processes, continuous improvement, etc. So let's talk today just about one topic of that House of Quality. As anything in life, there are advantages and disadvantages. So this is a list of advantages and of the use of standards. I'll let you a few seconds to read them. So as you can see, there are a lot of advantages. But as I mentioned, there are also some disadvantages. And the biggest one is not the cost of buying a standard. the biggest cost is the cost of implementation of a standard. It takes many days, many weeks, and sometimes many months, depending on the size of the organization and depending on the culture of the organization to implement standards. But the bottom line, the real bottom line for industry and government organization is it worth the cost? So for every dollar that you invest in the application of software engineering standard, how many dollars do you save? And here you can see that there is a significant contribution of standard to the gross national product. So it means that it has also effects in thousands and thousands of companies and government organizations in countries. So let's talk about quality and productivity issues. So this is the four components of the cost of quality, the cost of a project. So if we were perfect, 100% of the cost of a project will go in the cost of execution. But since we know that we are not perfect, we are doing evaluations like testings and reviews. And if we are intelligent, we'll be learning from our mistakes and we'll be improving the tools, the methodology. Okay? And as you can know, standards are a cost of prevention. And since we're making mistakes, then we'll have to correct those mistakes. And this is what I call the cost of rework. And my question to you as professors, as students and people from enterprise and government organization is, what is the percentage of your budget that goes into that cost category? So just to give you a hint, this is a citation that was published a few years ago, and I'm asking you to guess what is the number hidden behind my blue box. And it is about 40 to 50%. So it means that 40 to 50%, about 40 to 50% of a project budget, as an example, is wasted. And I say again, it is wasted. So 1 hour out of 2 is wasted before we don't do things correctly. So my talk to you is, if you don't change anything, you cannot expect different results or better results. If you have 50% rework, and by the way, 50%, I've seen in companies sometimes that some project go to 80 and 90% of rework. And this is one good recipe for disaster and bankruptcy. So let me give you an example of a cost of quality curve. This is the cost of non-conformance, cost of rework of a real company called Raytheon. And this is the cost of prevention and evaluation. So as you can see, as they were investing in evaluation and prevention, the cost of rework went down. It went down from 41%, okay, gradually went down to 18%, 11%, and eventually 5%. So by putting in place preventions, okay, as an example, standards, okay, you can reduce the cost of non-conformance. In other words, if you're using knowledge that has been captured from thousands and thousands of projects, you don't have to reinvent the wheel. Okay, so let's have a look at the 2911 series of standards. And before, this is for you a picture of the evolution of standards since the 1987. So as you can see, the first few years it was quite slow, and then they gradually picked up speed as we were learning from projects. But unfortunately, as I said before, nothing is perfect. So software engineering standard will not give you a guarantee of achieving quality, cost, and schedule objectives. But if you do it right, okay, if you do it right, then you will increase the confidence of delivering your functionalities with quality within budget and schedule. Quick walkthrough. This is a very wide portfolio of standards. I want to show you that everything you do in software engineering, there is a standard that you can use. So there is a standard about vocabulary, if you look on the left side. There is a body of knowledge that says what should an engineer, software engineer knows when he graduates. There are software lifecycle and system lifecycle standards, one of which is the 29110 that I will be presenting in a few minutes. There are standards about documentation, about requirements, about architecture, about testing, maintenance, project management, risk, measurement, software quality, software measurement, and tools and methods. So as you can see, there is no reason. You cannot say, no, there is no standard that applies to my work. As you can see, there are a lot of standards. So within the SC7 group that develops systems and software engineering standard, my working group 24, is involved in developing standards for very small entities. It has been established in 2005, and yet there are many countries that participates to the working group, one of which is Mexico, and two of the members of the organization of SIMS, Yezel and Mirna, are both experts that have been delegated by Mexico to the WG24. So let's talk about what we have done. So when we say very small entities, you can see the definition at the bottom. It could be a team, it could be a project, a department having up to 25 people. So it could be a team in a large organization or just a standalone team or a startup. Okay? So we have developed a roadmap, 4-stage roadmap. So the initial guide or profile is for startups and small projects. We have the basic guide for one team doing one project. And if the VAC evolves, then there is the intermediate profile or intermediate guide where many teams will work in parallel to work many products. And we want to help VACs in sustaining and growing. So we provided the advanced profile for that. So let's have a look at one of those guide, the basic profile guide. Let's have a look at the inside of it. So there are two processes. Now, once the customer comes and knocks at the door of a VAC with a list of needs, the VAC makes a decision to sign the contract, as an example, and it will trigger the project management process. And the first activity that will be done is a project planning. Then once a project planning is approved, it will be executed. And then you see the standard software engineering task. The first one is like a kickoff meeting where the project manager or the team leader will introduce all the team members, will present the context about that specific project, the objective of the project, the documentation that will be developed for that specific customer, as well as the process and tools that are going to be used, and the calendar. So as you execute the development of the software, you evaluate against your plan. Are you late? Do you have changes to make? And eventually, you'll be delivering your product to your customer. So even though I've illustrated here the white boxes in like a waterfall approach, it is just for illustration purposes. See those white boxes as Lego blocks, and you can assemble those Lego blocks using Agile, using Scrum, using the life cycle that you prefer. Let's have a look for a few minutes at one task of that activity, okay, the requirements activity. Let's have a look at one task. And this is how each task is documented in the 29110. So on the left side, you see the roles. So in this case, the customer and the analyst will validate the requirements, and the analyst will obtain the approval of the requirements from the customer. There is some text that explains that in more details. The input product that is required to perform this task are the verified requirement specification. And once this task has been completed, then the output are the validated requirement specification and the results of validation to demonstrate that the validation has been performed and the customer approved the requirement specification, and the project will start doing those. So let me give you 4 examples of 4 different VACs that have implemented 29110. So a startup in Peru. It was a startup created by 2 software engineering graduates from University of Lima, and that hired another 2 people. They implemented the basic profile in Agile mode, and for a project of 100 hours, they had 18% rework. A small company that developed cosmetic products had only 1 software developer, and he used the entry profile on a small project with 12% rework. Another startup, 2 developers, 990-hour project, also with the basic profile, 12.6%. And remember, I told you that the definition of VSE means that you could have a small team or a small department within a large organization. And this is an example. Okay, so this organization is providing electricity to the 8 million people of the province of Quebec, where I live. In this organization, they have a division of 2,000 people that take care of IT, and they take care of about 2,000 applications. And in this huge organization, there was a 11 people team that developed a software, a web application using BASIC with Scrum, and it was a 1,500-hour project, and they had the percentage of rework of 9.6%. So here you can see a spectrum of the VSE. Now let's go back to that curve that I've showed you before. So the startup at 18% rework, another startup at 12.6, the cosmetic organization at 12, and the large utility at 9.6. So my message here, okay, very important message, is implementing proven practices of standards, as an example, like the ISO 29110, accelerate the maturity of VSE. So instead of starting from scratch and making a lot of mistakes, okay, and losing time and being frustrated, you are learning and using proven practices from a standard. So for those of you who are doing cooking and are using cookbook, it is similar. Okay, the metaphor is that it's a similar approach. So you're using proven practices, and this is why the percentage of rework is much, much smaller than if you were starting from scratch. So we produced those standards and guide, and back in 2008, we did a survey of the users, the VSEs, also of the customers and professors. So one of the questions we ask is, are you happy, okay, with your improvement in productivity? So as you can see in the bottom with my red bracket, the VSE saw productivity increase, okay, within the first month, the first 3 months, or the first 6 months. So it is not something that takes years to see improvement. It is 29110 is a set of practices that can be applied right out of the box, if I can use this expression, and you can see within the first month, you can see improvement. We also ask about the overall satisfaction. So you can see that 89% said that they were completely or largely satisfied with their implementation. Now, it's very good thing to have happy VSEs. Now we also wanted to find out if they were happy customers of those VSE. So here you can see that close to 80% of the respondents were completely or largely satisfied with the software produced by VSEs using 29110. If you want to know more, you can look on my website at the ETS at the university. I provide the address at the bottom, and you can have information in English, French, and in Spanish. So let's move now to another topic, the teaching of software engineering standard. And in the paper that we have written, Myrna and myself, we talk about one success story. There are many, but just to illustrate the purpose, the advantage of using standard, we use the example of a university in the state of Zacatecas. But the success that I will be talking here has been applied in many universities around the world. So a method has been developed by researchers and professors from CMAT to help accelerate the transition of 29110 to both VSEs that are industry, as an example, and this is quite innovative, also to software development centers of universities. So software development centers of universities have developed an environment which emulate a real organization in a real industrial context with sometimes real external customers. And the SDC have implemented the process using the 29110. So to help, yes. Oh, so it looks like that I've skipped a slide. Sorry, for one reason, I was talking to myself. Sorry about this. So to save some time, to reduce the barriers, we have produced the 29110 standard in different languages. When I say we, people from different countries, like people in Mexico and people, let's say, in Uruguay and in Peru and in Brazil, have translated the standard in different languages. And also, many countries have adopted the standard as a national standard. And we have also developed teaching material to help the teaching. Here you can see the list of countries that are teaching 29110. We have over 20 countries that are actually teaching. And as an example, in Thailand, we know that at least 10 universities are teaching 29110, and they have been teaching since 2009 in some universities. So let's have a look at the survey that has been conducted 2 years ago to software engineering professors. So to publish that paper, to get some results, we survey 30 software engineering professors. So we know that this is a very small subset of all software engineering professors around the world. So we are aware of that. Okay. So we asked them 3 questions. We asked them, why do you think there is a lack of teaching of standards at universities? We asked them, what are the benefits that could be obtained when teaching standards in universities? And third question, we asked them, what needs should be satisfied to enable professor to teach standards in university? So I will be answering, looking at just one question. If you want to know more, please have a look at the paper. So first things is professors have observed that students develop higher quality on time and within the resources available. And students develop a comprehension that standards could help them and they're not their enemies, okay? And students have improved their performance, both in productivity and quality when developing software. Again, if you have 50% of wasted time, it means that somewhere there will be some crisis to deliver software at a certain date. And it means that most probably that in this case, the productivity is quite low and maybe quality will suffer. So if you're using proven practices, you may be able to deliver quality software within schedule and budget. Also, students have learned that software engineering is not just about coding. They have learned the importance of other activities. As I showed you before, 29110 covers all the dimensions of a project, okay? Both the technical aspect as well as the management aspect. And you may not be happy that we talk about the management aspect. The reason why we have put the project management process is because most software developers are not very good at project management. Most of them have never done project management when they were sitting in university. So we said that we want to help VSCs, and to help VSCs and also to help students, we introduce a project management process. And it is not a complex thing. Okay, again, we have produced a project management process that describes, like I showed you before, with a list of tasks and inputs and outputs. Easy to follow. So students are better prepared to work as professionals. Also, they've learned to work as a team. Okay, and also students that have worked with standard have been hired in university in quality departments. So, quick conclusion. So today, because of the lack of time, I was able just to show you one small dimension of the house of quality, the standards. Okay. If you want to know more, if you want to learn more, and this is my marketing pitch, you can obtain, if you read French, the two books on the left side that have been published in French back in 2011, or the English book that has been published 3 years ago in English. And great news, and Mirna will be talking about this in a few minutes after my talk. The book has been translated in Spanish, and I was told that the translation is completed. And also the book will be translated in Chinese in 2022. So why am I showing this? It's to show you that software quality assurance has demonstrated that is very important, and countries all over the world have asked to have different version of the book translated in different languages, such that it will lower the barrier of adoption, barrier of teaching, and barrier of utilization by having French, English, Spanish, and eventually Chinese version. So you guys and girls working in software development, you will be in competition against people around the world. And in this case, you'll be in competitions against the Chinese software developers that will be implementing software quality practices. So conclusion. So not teaching software engineering standard to software engineering students should be considered a malpractice. Okay, so this is my conclusion. Okay, it is a malpractice not to teach proven practices of software engineering standards. All other engineering disciplines, by the way, if you are working in mechanical engineering, chemical engineering, electrical engineering, they are using standards on a daily basis. Sometimes they don't read the standard as it is, but they use a process. There's mechanical, electrical, or chemical engineering process, which have embedded software engineering practices right there in the process. The correct use of appropriate software standards should increase the confidence of achieving the objectives of providing all the functionalities with all the quality characteristics within the budget and schedule. It's easy to produce all the functionalities. It's a little bit more complex when you have to produce all the quality characteristics like maintainability, portability, etc. And if you have to also meet the double constraint of schedule and budget, that becomes more tricky. So this is why we're saying don't reinvent the wheel, use proven practices. So if software engineering professors do not teach software engineering standard to students, we could be in for another last decade. In other words, we'll be losing time again and again and again. Sorry, I had to mute someone. The 29110 series was developed specifically for VACs having up to 25 people. So it includes startups, okay? We have developed a roadmap, a 4-stage roadmap to help them, to guide them, okay? From the very beginning, even in school, even in universities, from startups to grown-ups. And I'm telling you that not only software engineering professors and students, but also developers and managers must use the knowledge documented in software engineering standards. Okay, so if you could learn about the standards when you're a student, then when you go to work as a software developer or software engineer in an organization, then you'll be bringing with you the knowledge that you've gained, and by the fact you'll be transferring that knowledge from the university to enterprises or to government organizations. But to do that, professors have to teach software engineering standard to software engineering students. So thank you very much. We'll have a question period.
Thank you, Claude. You hear me?
Yes.
Okay. Thank you very much. Do you have questions? ¿Tienen alguna pregunta? Por favor, levanten la mano o escríbanla en el chat. Anímense. Tenemos tiempo para 3 preguntas. principalmente profesores. Estudiantes. No hay preguntas. Ah,
Questions?
yes.
Okay.
Blanca, ¿quieres hacer la pregunta tú? ¿O prefieres que la haga yo? Okay. Blanca Dina asked you about if it is possible to do a transition among between Microsoft, level 1 of Microsoft to the ISO 29110 standard.
Okay, excellent question. I didn't have time to talk about this, but when we started the development of 29110 back in 2005, we had a good contribution, I would say an excellent contribution from Mexico. And the contribution of Mexico was that Microsoft was used as an input to start the development of 29110. So Microsoft was developed from memory, because it's 15 years back in time, but if my memory is right, Microsoft was developed or designed having in mind about 50 people in an organization. So, and we were developing 29110 having in mind 25 people. So we were talking about the same size. We're not talking about the difference between a standard developed for thousands of people and the standard developed for 25. So we said Microsoft was an excellent input to develop our 29110. So if you've been using Microsoft, you'll see that there is a lot of resemblance with 29110. And by the way, there is another guide, which I didn't have time to talk about, that does the bridge the gap between, let's say, the basic profile that I've shown you a few minutes ago and the full Microsoft. So if you want to look at the organizational management guide, it covers everything that if you're using Microsoft, if you use 29110, the basic profile and the management organizational management guide, then you should have almost a full coverage between those two. So yes, the migration between them is quite easy, especially that 29110 was designed with as a main input Microsoft back in 2005, 2006. So I hope I answered your question.
Yes, Blanca says, thank you. We have another question. Daniel, ¿quiere de igual manera? ¿Quieres hacerla tú? Okay, Daniel Arredondo menciona, do you recommend some strategy that you recommend in order to teach or to have a strategy to teach standards, software quality standards to students?
Yes, and this is a question that I've been asked all over the world. How do you teach software quality assurance? Not only teaching, showing slides, okay, because showing slides or reading a text is easy, but you have to learn how to use the software quality assurance practices. So the way that I've done it at ATS at my university for over 20 years is there were class time, okay, so 3 hours per week in class where they were learning, let's say, the theory, if I could use this expression, about software quality assurance practices out of the house of quality that I've showed you. And each week, student had to do a project, 2 hours per week over one complete semester using 29110. So as we were teaching the basic software quality assurance practices in class, students were starting to use 29110 in a project. They were given a list of needs. As me, as a professor, I was playing the role of a customer, presenting to the students my needs as a president of a company. And then as students were applying the different processes. Then we were showing let's say the concepts in class, and the week after they were applying the concepts in the project. As an example, and all projects have changes. Okay, there is no project there is no change from the beginning to the end. So there is a little mechanism in 29110 where you address those changes coming from either the developers or the customer. It's called a change request. So at one stage of the process, at week 5 or 6, I come in as the president of a company. I said, oh, I changed my mind about one requirement. I want to do this instead of that. And the reaction of the students say, oh, so that is quite a change. Do we have more time? Do we have more calendar time? And the answer was no. Life in the real industry, you have a set deadline, a set budget, and you have to meet the deadline and the budget to deliver your software. So they had to learn how to use the change request and also to modify, because they had to rework. Naturally, they had to rework some bits and pieces of the requirements of the architecture. They had to modify some pieces of code. They had to modify also some parts of the tests and re-execute the tests such that they would deliver the product at the end. And during their project, they also had to do some reviews. Remember when I talk about the case study that I presented to you, the student didn't do a correct inspection. So we show to the students in class how to do a correct inspection. And when they do their project, they perform 2 or 3 of those reviews such that they learn how to do practical review in real life. So in other words, the house of quality that I've shown you is like a toolbox. So in class, they learn about the tool, and in the project, they use the tool out of the toolbox to develop a project from beginning to the end, up to the delivery to the customer. And during the project, they measure the time, they measure the rework, they measure the effort, such that, because when I tell them that they could have 40 to 50% rework, at the beginning, they laugh at me. They say, oh, no, we are much better. We are good students. We have just 10% rework. And I say, haha, just wait. And as they gather data, okay, and as they improve, they see that the first steps, they'll do a lot of mistakes because this is the first time that they're using a process, and they're learning as you are learning as student. And as they learn, they improve. As they improve, they do less mistakes. And the overall percentage of rework may be 20%, but 20% is a lot more or less than the 50% that I've shown you. Okay, and 20% consider the fact that they have been using practices for the first time. They've been using the 29110 process for the first time. So 20% rework is a success, very high success. So if they had to reuse the same process for another project, then I'm quite sure that the percentage of rework will go down gradually, eventually to maybe the 5-6%. Why 5-6%? As I said, nobody is perfect. We'll still have to do some rework. That's part of life. So I hope I answered your question.
Yes, thank you. We have 3 more questions.
Okay.
3, I think 4.
Okay.
The next question is, what knowledge and skills are required for students before using 29110? And the other is, what is the complexity of software that a student can carry out in a semester?
The analogy that I've used before, a cookbook. So for those of you who have done cooking, and if you, let's take the analogy of cooking a chocolate cake. Okay, let's say that you have never done a chocolate cake before, but you are wise. Okay, you purchased a cookbook, and you identify the type of cake that you want to develop, and you look at the list of ingredients. You got this. You look at the list of tools that you need to develop to produce that chocolate cake, and you look at the steps to find out if you could understand the meaning of each step, and you start. Remember, each step of the process shows you the inputs, so the input ingredients, the tools that you have to use, what you have to do, and then you get the output, and you continue the process to build your chocolate cake, the glazing and all that. And at the end, you will end up with a very good chocolate cake. Okay? It may not be perfect the first time, but you'll end up with a very good chocolate cake for the first time of your life. Okay, so same thing with 29110. First time you'll be learning, but as if you remember the task that I've showed you, okay, it's not magic. It's not. We're not asking for impossible things. We're just asking in that example to meet with the customer and walk through each requirements, because the customer came to you with a list of needs. I want this, I want that, I want to color this, I want a pointer there. And then you have transformed those needs in requirements. And you want to make sure that you have not missed any needs. You want to make sure that you have correctly interpreted the needs of the customer. Okay, everything is correct, nothing is missing, there is no ambiguity. Okay, and once both of them, you and the analyst, agree, then you sign a document saying that you did the walkthrough of the requirements. Okay, maybe you've modified a few because you discovered that you had maybe not the perfect comprehension of what the customer wanted. Maybe as you were discussing, the customer says, oh, I forgot one requirement. Then you add that other requirement. And at the end, you say, okay, we're happy. We have a baseline. Me as a project manager or the analyst from the VSC will sign. And you as the customer or the representative of the customer will sign saying that you have approved the customer, the requirements. And based on that, we will be kicking off the other parts of the development process, the architecture, the codes, and the test cases, etc. And in a few days or a few weeks or a few months, depending on the size of the project, we'll come back to you and we'll do an acceptance of all the requirements in front of you, the customer or the users of the software. And we'll demonstrate to you that each requirement have been implemented correctly. And then you'll be able to collect the final payment for that contract. So there is no miracle, there is no complex things. If you have learned the basic software engineering practices in class, then those are the practices that we are using in 29110, and those are the practices that are being documented in my software quality assurance book. Do we have another question?
Yes. Could you explain, please, how have you solved IEEE 1028 in your courses?
Yes. So before talking about that, I told you that we all make errors, and those errors will eventually materialize into defects. Defects in the requirements, defects in the architecture, defects in the project plan. Okay. So knowing that, I have to tell you, because I've been teaching software reviews all over the world, in America, in Asia, and in European countries also. And something to remember is software reviews are the most effective way to detect defects and eventually to correct those defects. I say again, software reviews are the most efficient way to identify the defects and correct those defects. Okay, so the IEEE 1028 describes different types of reviews. So there is a type of review called walkthrough, where you do, like it says, you walk through a document and you make comments about maybe ambiguities, missing things, duplications, and things like that. And also, walkthrough is a review that allows you to discuss different options. Let's say architecture A versus architecture B, discuss that and eventually make a decision, formalize that decision. And then once a decision is made, then developers will use the selected architecture to develop the software. Another type of review is called inspection. And the objective of inspection, the analogy is like a microscope. Okay, the microscope will allow you to see the germs that you cannot see with your eyes. The inspection is like a microscope, which will allow you to identify and see the hidden defects. Okay, because if they were evident, you would have seen them and you would have corrected them. But unfortunately, the most damaging defects are hidden, but you can discover them. Okay, the good news is that you can discover them. When I say hidden, as an example, someone can write a requirement sentence, and in the mind of that author, the requirement sentence is clear. But could that requirement sentence be interpreted the same way by the tester that will have to develop test cases for that requirement? Could that requirement be interpreted differently by the people that will be developing the architecture? Will that requirement be interpreted differently by the maintainers that will be maintaining the software for the next 5, 10, 20 years? And most probably, you will find that there is a slight difference of interpretation between those 3 or 4 people. And this is why the ambiguous, what we call the ambiguity in the requirement, is one of the biggest errors. The highest number of errors that we identify when we review document is the ambiguity. It's not clear. It's clear in the mind of the author, but since we cannot do telepathy, we have to use software inspections and walk through, review each requirement one after the other to make sure that we have a correct understanding and the same understanding amongst the customer, the manager, the requirements engineer or requirement developer, the architect, the tester, and the developer. And you will see very often that there is a gap between that. And this is when you discover that there is an ambiguity, that you can correct that ambiguity. So that will save you a lot of rework, okay? Because if you took the wrong interpretation and developed the architecture, the code, and the test cases, and you start doing the tests, then the customer at the acceptance test will say, oh, this is not what I wanted. This was not my interpretation. And then this is why you have to go back and modify the requirements, modify the architecture, modify the test cases, rerun the unit test, the system, the integration test, the system test, and then get the final approval of the customer. So if you want to reduce the percentage of rework from the 50% and 60 and 70%, okay, reviews is very, very, very powerful, and it is not complex. Okay, the only high technology tool that you need to do, you don't say yes, is this. Okay, a $1 pencil. Okay, and your brain cell. You don't need a computer. You don't need. It's not rocket science. It is like you were studying out of a textbook. In this case, you will, let's say, studying the requirements or studying the architecture to identify hidden defects. So I hope I answered your question.
Thank you very much. Okay, Claude, I'm going to present your recognition. Yes, okay, I'm going to read it. So in recognition and appreciation to Dr. Claude Laporte at the International Conference since 2021 with their keynote, Not Taking Software Engineering Standards to Future Software Engineering, Malpractice. Theme was held at the University Technological of Torreón, Coahuila, to the October 22. Time, Raúl Martínez Hernández, rector de la Universidad Tecnológica de León, Hugo Montoya Díaz, presidente de Cañete, Coahuila, y Jeffrey Mejía Miranda, presidente del CIN. Claude, as always, thank you for your excellent talk. I think it's very important for us to have a people as you. Thank you very much for accepting participate with us in all the editions of this conference. I'm going to change my speech. Muchas gracias a todos por estar aquí. Les recuerdo que tenemos un día completo de conferencias magistrales y también los que tengan que integrarse a sus talleres. Los esperamos en los talleres. Esperemos que todo el día sea muy provechoso para ustedes. Están colocándoles en el chat los links a los cuales se deben de conectar dependiendo de las actividades que hayan elegido. Pues nada más para finalizar, como lo mencionó Claude, un grupo de investigadores de diferentes universidades de México, de Colombia, de Chile, de Perú estamos haciendo un esfuerzo por hacer esta traducción del libro de aseguramiento de la calidad, porque creemos que puede servir como base para, o estamos seguros que puede servir como base para las universidades a nivel Latinoamérica en español, para que todo el mundo tenga más fácil aprender temas relacionados con la calidad. Creo que es un excelente libro y esperemos tenerles noticias buenas pronto. Thank you very much again, Claude, and I hope to see you next week, no, in 2 weeks. Thank you very much.
And for those people that are in different countries in Latin America, if you want to have presentations about the topics of software quality assurance that I presented, I'll be more than happy. So just contact me, send me an email, and I'll be happy to make presentations to your students, professors, or people in industry. Thank you very much. Bye-bye.
Thank you. Como lo mencionaba el doctor, quien esté interesado